we want to express x over x minus 1 all squared times 3x plus 2 in the form a over x minus 1 plus b over x minus 1 all squared plus c over 3x plus 2. X minus 1 all squared is known as a repeated factor. The x minus 1 essentially is there twice. This identifies this type of partial fraction as a type 3. The x minus 1 all squared is dealt with by these first two terms. So we deal with the x minus 1 squared in the denominator by putting a over x minus 1 plus b over x minus 1 all squared. The linear factor is dealt with in the normal way. So we have x over x minus 1 all squared times 3x plus 2. This is identical to a over x minus 1 plus b over x minus 1 all squared plus c over 3x plus 2. We're going to multiply right through by the denominator here. If we do this, on the left we just get x. Multiplying this term by this cancels one of these x minus 1's, and therefore we get a multiplied by x minus 1, 3x plus 2. When we multiply this term, x minus 1 all squared cancels. And this leaves us with the b multiplied by 3x plus 2. When we multiply this term, the 3x plus 2's cancel, leaving us with c multiplied by x minus 1 all squared. If we choose x to be equal to 1, we can make this first term disappear, and we can make the last term disappear, since 1 minus 1 is 0. That just leaves us with the b term. So this is 1 is equal to b into 3 lots of 1 plus 2. So 1 equals 5b, and b is therefore 1/5. If we now choose x is equal to minus 2/3, 3 times minus 2/3 is minus 2. Add 2 is 0. So these two terms will disappear. Substitute in here, minus 2/3 will be equal to c into minus 2/3 take 1 all squared. So minus 2/3 is equal to c multiplied by minus 5 over 3 all squared. So minus 2/3 is equal to 25c over 9, and this gives us that c is equal to minus 6 over 25. At this stage, we've chosen the only two possible values of x that actually make terms disappear. We chose x equals 1, and that made the term involving a and the term involving c disappear. We chose x is minus 2/3, and that made the term involving A and the term involving B disappear. So to proceed to find A, we need to use another method. We can do it by choosing just any other value of x. 0 is often a good one. 0 is equal to A into 0 minus 1, which is minus 1, and 3 times 0 plus 2, which is 2. We also get B times 2, and C times minus 1 squared, which is just C. So 0 is equal to minus 2A plus 2B plus C. This gives us 2A is equal to 2 lots of B, which is 2/5, plus C, which is minus 6 over 25. And this gives us 10 over 25. Take away 6 over 25, which is 4 over 25. Therefore, A is equal to 2 over 25. We could also have found A by comparing coefficients, and we'll approach it in this way in the next example. Now that we have the values, we can substitute back in. A is 2 over 25, put the 2 on the top and the 25 underneath with the x minus 1. B is 1/5, put the 1 on the top and the 5 underneath with the x minus 1 all squared. And C is minus 6 over 25. We can put the minus here, 6 on top and the 25 underneath with the 3x plus 2.